Great. So pretty simple problem. I thought this one teaches a good little JavaScript. Not sure we call it a trick, but a nice way to use a function here. Complete the solution so that the function will break up camel casing using a space between words. I tend to think that these problems, they often come up one way or another in an entry-level interview, some kind of string manipulation. I think they're good as far as as part of a holistic interviewing process. I think these kind of problems are quite good. No tricks here, no big data structures, nothing tricky. Just take a string, look at some rules and figure it out from there. So they give us 3 examples. Of course, our base case is going to be an empty string again, empty string to empty string. Here we just have a single word, all lowercase, and again, that word just returns itself. Here we have essentially 2 words. We know that because there is 1 capital letter, which is how camel casing is written, with every word after the first capitalized. And we're meant to return both words with the C still being uppercase, but with a space between the words. So like usual, let's go over to our tests and delete what's here. It handles an empty string. So I would start this one out. And we're going to say we've got an empty string and we expect an empty string. You have an option to put a 3rd argument here if you want to write a message like, failed on empty string. I don't typically do that. Testing takes long enough as it is. We'll leave it here for right now since it's already there. All right. And of course, if I were to run this now, this function is not returning anything. So this fails. We're going to return an empty string. Why do we return an empty string? We return exactly what it takes in order to get this one test to pass. And then we're going to move on and complicate our solution as we go. Okay, that looks like it's doing just fine. I wonder if we can have a string of more than 1 space. I don't think so. We'll ignore that idea for now. Handles a single word. And this should be pretty simple, right? We say, here's a word and we expect to return word. I'm just going to delete this message here. We'll run that. We fail. Easy enough to change this. We're just going to put in here string. We're going to return the same thing that was passed in. We're going to return it without doing anything. And now we're passing this test and this test. Okay, we're meant to overwrite things that we've done before, right? I had just an empty string here. I certainly don't need to do something like if no string return this, otherwise return this. This is not necessary. And when I'm doing test-driven development, I'm not looking to just overcomplicate my code. Quite the opposite. I'm thinking, can I replace something I've already done? Can I put a variable where I used to have a hard-coded value? And step by step, I just work through it. That's why the tests are all here. And we can always check for backsliding. And if we're backsliding, great, we just do Control-Z or whatever to get back to where we were. And then we take another approach. It's kind of like a save point on a game, right? Whenever I pass all my tests, it's like, okay, that's a save point. Now I can always come back to here and restart. If I die, if I fall off a cliff, I can always come back to here and keep going. And just like save points, we should save early and often so that we, I'm not much of a gamer, but everybody knows this. Like you save early, save often, and that way you can always just restart where you were, at least as often as the game allows. And with software, the game allows it all the time. All right, let's make one more case here for single word. Not that it's going to be much different, but what did they tell us here? They said identifier. Sure, we'll use that. And we test that, and we're not going to have any problem there. All right, now we get to the harder part. It handles words with camel casing. Of course, this is actually where the problem lies. Word separator. We want word space separator. There we go. This one we'll delete. We run that, and we fail. Of course. So now we ask ourselves, okay, what are some different approaches I could take here to do this properly? Let's just map out a couple of those. One would be iterate through the string if current letter is capital, then we want to, actually this relies on create string for separated words, something like that. Here we say add a space to separated words, and then something like move ahead. Oh no, then we just want to add character to string. And if the word is not capital, then we want to do all the same, else add character to string. And finally, we would return the string for separated words. So we might change the variable name here, but that's the idea here. So we're going to go all the way through the string. If we see a lowercase letter, we're just going to add it to our string here. If we see an uppercase letter, we're going to add a space, and then we're going to add a string. In fact, we can simplify this by just writing this like this. If we see a capital letter, we're going to add a space, then we're going to add that character to the string, and we keep going. Quite simple. Let's just write it. It's so simple, we might as well write it. So here I'm going to say, let separated words is equal to an empty string. Then I'm going to iterate through the string. So we'll do for let char of string, where char here is going to be the character itself, since I'm using a for of loop. If char, now how do we know if it's capital? How to know if it's a capital letter? It's a whole nother little problem there. Let's come back to that actually in 1 second. Add space, so format that correctly. Here I want to do separated words plus equals an empty space. And here I want to add same thing as this, plus equals char. And let me just get my indentations here correct. This is good, good, good. Okay, so we need to come back and finish this part. How do we know if it's a capital letter? Probably an easy way to do this is to do, I always forget if test comes first or last. We need a regular expression that looks for A through Z of capital letters dot test R char. There's certainly other ways to do this, but this is a pretty simple, straightforward way to do this. Let's give it a run and see if I made a mistake. Word separator. Oh, I did make a mistake, which is I didn't finish out the last part, which is returning now separated words rather than just string. And there we go. That works fine. Go through every character, check if it's a capital letter. If it is, add a space. And no matter what, add that character to the string. And there's our separated words. We can write one more test before I'm going to actually delete this solution and do a different one, or at least comment it out and do a different one. So word separator has letters. Here we want word separator has letters. Let's go ahead and test that. And we see, yep, that still works. So that's a quick, easy way to go through this problem and separate it out. However, let's comment all of that out and let's do it a different way. Okay, so we have in JavaScript a replace function, string dot replace, And what replace does is it takes some target, let's say an A, and it replaces it with some other thing. Let's say a lowercase a. Let me see if I can fire up Replit real quick. We can mess around with this. Great. Just copy this out. So if I were to run here a string of capital A, B, capital A, capital C, lowercase c, and I run this, I expect to get lowercase a, B, lowercase a, capital C, lowercase c, because all of the uppercase a's will be replaced with lowercase a's. Let's take this and we're just going to run it right here. And we see, oh, kind of, but A, yes, the first one is replaced, but the second one is not replaced. And then the other letters are exactly as we would expect. So replace does not work quite the way we think it should here, being that it only looks at the first time it sees a character and then it replaces that. So let's look at how we can change that. The first thing to know is that JavaScript now includes replace all. It didn't have it for a long time, but it has it now. So let's run that. And now we see, yep, that's what I expected initially. If I run this function replace all with the exact same arguments, I get A, B, A, C, C. Cool, capital C, lowercase c. So that's one way to solve it. Another thing we can do here is going back to replace. I can take out this string literal and I can put in a regular expression. So I'm going to put in here a capital A, and then I'm going to use the G flag. That means not just find one capital A, but find all capital A's through the whole string. And let's run that. And now we see that does the same thing as replace all. Cool. Now in our problem, what we're looking for is not just a capital A, but any capital letter. So I suppose we could chain 26 times, replace a capital A with not a space, but or not a lowercase a, but a space and a capital A, and then replace a capital B with a space and a capital B, and et cetera, et cetera. I won't bore you with doing that 26 times. We could chain those all and actually it would work, but that would just be extremely inefficient and bad looking and take forever to write. So we don't want to do that. We could look for a regular expression where we say any capital letter A through Z through the whole string should be replaced with a space and itself. But how do we reference itself in here, right? I want to say, well, if it's an A, put an A, and if it's a Z, put a Z, and if it's a D, put a D, etc. There might be a way to do that actually with regular expressions, but I don't know of it, and there may very well may not be a way to do it. So we have one more tool left to us inside of replace, and that is we can put in a regular expression or whatever we want to match. And as our second argument, we can actually write a function. So here I say, given whatever character is passed to me from this regular expression, I want to return a space plus that character. So now this says, okay, this is going to match some character. Incidentally, it's going to be an uppercase letter between A and Z. Then it's going to pass that as the argument to this callback function here. And this callback function is going to resolve, and it's going to say, oh, you want an empty space plus this character. So we want to replace everywhere in the string that has a uppercase letter with a space and that character. And with that, I think we can pass the problem just like, whoops, I did not mean to click on that. Let's get this up a little bit. There we go. We test it. And there we go. In one line and not too many characters, we've passed the whole problem. We don't have to write this whole loop through. It still is essentially the same runtime, but it's a really nice use of replace here. Just remember that you can use literals or regular expressions to match, and then you can use literals or a callback function in order to for your second argument. Any questions on that? Okay, let's make sure that this passes all the tests. It does. I'm going to go back one more time to my other solution to make sure it passes the full. A bit tricky here with the. Do that correctly. This, and this, and this, and this. Yeah, I just want to make sure that also passes. And it does. So either one will pass. But this, as far as getting things done in a short amount of time, and this to me is very readable and properly written code that just happens to be a whole lot more concise than writing an iterative loop like this. Okay, we're good.